We are live. Good evening, everyone. Welcome to our session. Welcome to the Machine Learning Study Jam for GDG Nairobi. We are happy to have all of you join us today. My name is Ngesa Marvin. I'm one of the organizers for this community, particularly focusing on machine learning. And today, I'm joined with a couple of other amazing organizers. I'll let them introduce themselves, starting with Philomena. Philomena.
Hi everyone, my name is Philomena Bura. I'm a data scientist. Pleasure to be here. I also lead the Women in Data community, and I'm a WTM ambassador.
Awesome. Next, we'll have Daisy.
Thank you, Ngesa. I love the representation of women here. The fact that you went from Philo to me, that's just a segue from my introduction. Good evening, everyone. I'm Daisy Okacha. I'm a data and machine learning engineer. And I am a co-organizer with GDG Nairobi around machine learning events and partnerships. I'm super excited to be with you today, and I look forward to engaging and learning more from you. Just a tip, remember to engage and ask your questions as much as you can.
Thank you, Daisy. Let me hand it over to Brian Kai Manyumba.
Thank you, Ngesa. Hello, everyone. Hope you're having a great evening. Thank you very much for making time to join us this evening. Thank you very much, Louise. I'm seeing your comment. Thank you very much for making time to join us. I'm Brian Kai Manyumba. I'm also a data scientist and technical writer. I'm so happy to share my knowledge with all of you today. This is something I'm passionate about, and I hope it will spark your interest to dive into machine learning even more. Back to you, Ngesa.
Yes, and now I'll take it to Victor Ashoya. Victor, can you hear us?
Yeah.
Okay, please introduce yourself to the guys on stream.
Okay. Yeah. Sorry. My name is Victor Sher. I'm one of the organizers, GDG Pwani, and I'll be here just to facilitate alongside the others. Thank you.
All right, thank you, Victor. And we're going to take you through a series of machine learning study jam for 4 weeks. Let me just share with you the screen to show you what you're going to go through. I hope it's this one. Can you guys see my screen? I think I need to add it. I'm double hatting as a speaker and a controller in the background. Okay, I can see it's there. Okay, Brian, is it full screen?
Yeah, not yet, Ngesa.
No, it's not.
And now?
It's now full screen.
Perfect. So welcome everyone to our machine learning study jam. They're calling it V2. I'm not sure why V2, but this is also our second machine learning study jam in the year. We had one from April to around May, I think around June, and now we're doing a second one. But this one is different from the other one because the other one was a cloud study jam, but with machine learning inside it. This one is going to purely focus on machine learning and also in using Kaggle notebooks. And this is just like another community event where we're going to give you an opportunity to learn from each other and also share resources or access resources from Kaggle Learn, ML books, and even free online courses. And of course, there are different tracks, but we've selected the track for Kaggle Learn. And this track is going to allow us to go through 4 weeks, where on week 1, today, we're going to go through introduction to machine learning. We're going to go through things like pandas and a series of other contents, including how the model works, the basic data exploration, how to load your data, how do you understand your data, and go through how to build your first machine learning model, and even doing things like model validation, what's underfitting, what's overfitting, and then go through the different Kaggle competitions. And probably we're talking about terms that you may not understand, especially if this is your first time getting into this, but don't worry. We're going to work with you from the very beginning and ensure that we get you over the first few bumps of getting started with machine learning. In fact, the whole idea of all this is to get you started with machine learning so that you can use this as a foundation to start learning and doing all this. And then we're going to have go to week 2, where we jump into intermediate machine learning, go into feature engineering, and then week 3 we'll jump into deep learning and even do things with computer vision. In fact, this is a week where we're going to tackle things like keras and TensorFlow and etc. And then week 4 we'll go into time series and also talk about AI ethics. So we have a series of content for you, and we're going to have amazing speakers from the community and even probably outside that are going to walk us through all this content. And all this is, we're going to use it as a build-up for Keras Community Day, because at the end of all this, we're going to have a major Keras Community Day event in Nairobi, and even in other parts of this country. And talking about Keras, we are also having a Keras Community Day for Sub-Saharan Africa taking place this weekend. So you can just go online and then probably check for them. But it's being organized by GDG Lagos. Okay, then I think I'm going to hand it over to Philomena to get us started. Philomena.
Okay, hi everyone. Philomena here again. So I'm going to walk you through introduction to pandas, NumPy, Seaborn, and Matplotlib. Let me just share my screen.
I can see it. Let me ensure that it's perfect. Perfect.
Awesome. Okay, so slideshow.
Yay.
Yeah, so what are this? So if you're new to data science, then this are four Python libraries that you need to be conversant with. So we have pandas, we have NumPy, Matplotlib, and Seaborn. I remember when I was starting out, I started by learning NumPy because there's no really formula to how you're supposed to learn it. But what I was told is it's easier if you start with NumPy. And then I went to pandas and then Matplotlib and then Seaborn. But collectively, they're all referred to like they're Python libraries and then commonly referred to as Python data science stacks or like the data science stack because they're all used for data science. So each of them serve a different purpose in when you're coming to work with them on your data science project. So often pandas, I feel like is the one that's used more often than not, especially when it comes to EDA. So EDA is exploratory data analysis when it's in data science, when you just want to explore your data. We have NumPy for numerical and mathematical operations, and then we have Matplotlib and Seaborn for data visualization. For those who may not know, data visualizations is just the basic graphs that we used to have when we were in primary, high school, or even university. Things like bar charts, line plots, and histograms and the likes. So these two libraries are what we use to plot this out on your notebook. So the notebook is where you actually do all this Python stuff on, and we'll explore that later on. So just I wrote a few things on the different libraries. So we have pandas. So pandas provides two main data structures. We have the series and data frame. I think we'll attach a couple of documents and explanations to delve further into this after this session because we can't really go in depth on them. So as I said before, we use pandas for something we call EDA, the exploratory data analysis. So you'll use it to perform your data wrangling, to clean your data. Most often than not, you spend a lot of time on your data cleaning it because you'll find that you may have some missing rows, missing columns, duplicates, and things like that. So in order for you to be able to build a proper machine learning model, you need to be able to clean your data first and prepare it for it to run through the model. So it has those functionalities that I've just mentioned. We'll explore some of them in the notebook. So the key features would be handling large data sets, data visualization, as I'd mentioned, aggregation and time series analysis. So can go to the notebook to just see a few pandas examples. And of course, don't stop here. We'll share this notebook with you, but you can already just use this as a reference to just get started. So when you're starting out, you of course need to install the library first. So you need something called pip. So you do pip install pandas. For most of these libraries, you just do a pip install and then the name of the library. So for in this case, it's pandas. And then after you install it, then now you import it into your notebook, the one that you're currently using. So pandas, as I said, is like used for EDA mostly. And so you'll find that this, what we have here between this and this is what we call a dictionary. And so when you have this dictionary, you assign it to a variable. In this case, the variable is called data. So in order for you to be able to perform this analysis on your data, then you need to have it in something we call like a data frame. So you need to convert it into a data frame using this function here. So we often use df to refer to a data frame in short. So we say PD, which is what we have imported here. When you import pandas as PD, and then you do pd.dataframe, and then you pass in this value here of the dictionary that you had before, and then you can be able to print the data frame. So as you can see here, we have it in the form of a dictionary, but then when you come here, you can see it's in the tabular format, which is easier for analysis, where you have the column names as name, age, and city, and then you have the rows here with this following indexes with John, Anna, Mike, and with their various details. So that's one of the ways you can be able to actually create a data frame using pandas. Also, you can use pandas to import a data frame. So we usually do it in the form of a CSV. So same thing, you assign it to a data frame df, and then you do a pd.read CSV, and then the name of the file that you want to import. So if you're working with a normal notebook on your local machine, you just need to make sure that you have the data frame that you're importing in the same location as the notebook, this notebook that you'll be working with. In this case, if you're doing it using Colab, which is what I'm using right now, then you need to have uploaded this CSV here on your Colab. We can share instructions on that later on, and then you can be able to import it. Load the data rather. So we have some basic operations that we often use in data science projects, just so you can be able to understand your data. So first of all, you use something called either head, or you use, I think it's usually tail. Yeah, so you do .head to be able to view the first few rows that you have in your data set, so that you can be able to understand the kind of values that you have there, so that you can know how to be able to manipulate it, or if it's what kind of data basically you have in your data set, especially if it's a very large data frame and you just want to get a very brief view of what you have. Another thing we often do is the descriptive analytics, which usually counts for the columns that have numerical data. So the descriptive the statistics is supposed to give you things like count, to know how many values you have in that column, and mean to know the mean of that column that you want to manipulate. In this example, the only numerical column that we have is age, and that's why it's only working on age. And then you have the minimum value, the maximum value, and the quartile values as well. So this will make sense when you want to do an analysis on your data in the EDA that I was talking about, if you want to be able to understand your data set, and especially to see if you have any outliers in your data. Because you'll be able to see the minimum, maximum, and the mean. And for example, if we had like a value, say, of like 100 here, you could easily identify it as an outlier because it's not within the same range that we can see in these values here. You can also be able to do basic things like selecting a column. We have the code here, filtering out the data. If you just want to see data that meets a certain criteria, then you can be able to specify, like in this example, you are specifying that you want data that's above 25. So I feel like there's a lot of code in this notebook. I may not have to go through all of them. I feel like you can go through it later, so you can be able to filter your data, sort out your data. In this case, you can sort out by age, grouping up your data. In this case, we are grouping by city, and as you can see, we're using Pandas still to do this. And then we have NumPy. So NumPy, as I said, is fundamental for numerical computations. So it's on case basis if you want to perform manipulations on your data, especially when you're working with arrays. So it's used mostly for mathematical operations. I'll walk you through some of the examples that we have here. Of course, you would need to install it like we saw previously, and then you import it, and then now you can do things like creating your 1D array, your 2D array. The syntax is the same. You call NP, which is what we're using to use NumPy in this case, and then you can perform the manipulations you want. Due to time, I will not go through all of that. And then you have matplotlib and seaborn, which I will try and go through together. So matplotlib and seaborn are used for visualizations. Syntax remains the same, especially for most visualizations, as you'll see. I personally prefer to use matplotlibs when I'm doing things like line plots, scatter plots, bar charts, the common graphs. And then when I am doing things like heat maps and distribution plots, then I will use seaborn. So basic examples, matplotlib, you need to import it first of all, and then you have to plot out the graphs that you have. So here we're just defining the data. So what we'll have on the x-axis and what we'll have on the y-axis. So across all the graphs that I've plotted out below, you'll see that we are putting a label. I think it's just best practice to put a label, a title, and also to put this plt.show at the very end so that you can be able to see it. So you can create a line plot. Of course, the visualization you choose to use, you should always make sure that it fits your use case. If, for example, you are plotting out data that's supposed to show trend, then the best thing that you could actually use is a line plot so that you can actually see how it's trending over time. And if you want to show the relationship maybe between two variables, you can also use something like a scatter plot. If you want to show the percentages, you can use something like a pie chart if you don't have too many columns at the same time, because a pie chart can get messy with too many columns. So basics, same syntax. You define the variables. Of course, it will change when you are using more complex data, but then I think this was supposed to just give you an introduction of how you can use pandas, numpy, seaborn, and matplotlib. So once we share this notebook, you can just go through the various examples and also delve into the different courses that we will share on Kaggle that's supposed to help you to walk you through this. I think I will end there, and I'll end by saying data is the lifeblood of decision making. And with pandas for analysis, numpy for computation, matplotlib, and seaborn for visualization, we have the powerful tools to transform data into actionable insights. Thank you.
All right. Thank you, Philomena. Thank you for that. Let me share my screen. Let me know if you can see my screen.
Not yet.
Okay. Okay. And we're going to share all these resources, so don't worry. We're going to share the notebooks and everything so that you can also go through them one by one. Can you see my screen now?
Yes, we can see your screen.
Perfect. Okay, so thank you for the awesome introductory session, Philomena. And now we're going to go through the Kaggle content. And if you saw our banner, we told you that we'll go through what Philomena has talked about, but also dig deeper into how machine learning models work. Then we go through the basic data exploration, how to load it, how to understand your data, and even probably take you through how to build your first machine learning model. Then we'll talk about something called model validation, and then go through what's something called underfitting and overfitting. Ideally, how to ensure that you have the best model when you're building all these models. First of all, how do you measure the quality of the model that you have? And after you measure the quality of the model you have, how do you ensure that it's the best you can get? It's not maybe the one that's trained with less data or the one that's trained with more data or the one that's underfitting. I mean, it's just right. It's also not overfitting. Then we'll also go through some basic machine learning algorithms, including random forests and even more. But probably I could just start with what machine learning is. And for me, machine learning is, I don't know, I find out that it's it's like matrix manipulation, or it's vector matrix manipulation, or I could just say maybe it's a branch of AI that involve the use of, let's say, algorithms to enable computers to learn from the data or even make predictions from particular data. Because what you're going to do is you're going to have some features from your data, and then have the model learn from these features, or try to fit, or try to have a function, or try to model the distribution of the features, so that next time, if you show it a new, let's say, image or a new kind of data, it will be able to check if that's what it had learned before. And here in Kaggle, of course, there's this part for how machine learning model works. And there's an example here where you probably have a cousin, and the cousin has been in real estate, and then they've invited you to join them in the real estate. And probably the cousin has invited you to join the real estate because you are interested in data science. So he'll kind of supply the money, and you will supply the models that predict how various houses are worth. And then probably at some point you may ask your cousin how he's been able to make predictions in the past, or how he's predicted real estate values in the past. And it could just say that it's maybe because of it's from intuition or something. But then at some point you realize that it's not because of intuition, it's because he's learned some patterns before, and he has used those patterns to make predictions for new houses that he's probably considering. And that's the same way that machine learning works. You have some data somewhere, you try to learn the pattern, and once you learn the pattern, when you're given a new data, you could think of it in terms of the pattern that you learned before, and then make a predictions depending on the pattern that you learned before. And machine learning generally works the same way. You also have probably, let's say, before having this session today, we had to make a lot of decisions. First of all, we had to check that if all our team members are available to do the session. And then if all of them are available, we check if we have electricity. And if we have electricity, we need to check if our devices are charged. And if our devices are charged, we have to check if we have internet. And if you have internet, we also need to check things like, have we tweeted? And do we need to tweet? And how is this going to affect the number of attendees? I mean, we need to ask a range of questions before we make a go or no go decision with this live session. And those kind of decisions, it's something that is kind of a sample tree decision, where at the end of it you can be able to split your data into small chunks and then make a decision at the end of it. And let me just go here. Probably we could now examine our data. I think I need to reshare my screen again. Go here, stop screen, then reshare the screen again to capture the new part. And this part is going to rely heavily on what Philomena talked about. I hope you can see my screen, the new part for it, data exploration. And of course, with data exploration, you're just going to use pandas to do all this. And I've told you that machine learning involves learning from data. And that means that before even you do machine learning, you need to familiarize yourself with the data that you're getting. And of course, you'll have like lots. Of course, you can go and check them one by one, but it's a lot of data. You need to have some tools that allows you to check on them. And one of these tools is what Philomena has talked about, which is pandas. So you may be smart, you can you can check them one by one, but we also have nice tools like pandas that give you amazing things like data frame that you can use to do data exploration or to work with this data that you're having. And you may think of a data frame as something that holds the type of data that you have, almost like a table, similar to what you have in an Excel sheet, or similar to an SQL in a database, or a table in an SQL database. And of course, you also have a range of methods that you can use, and they can help you to do things like, how can I read data that is stored somewhere, and how can I also read the data from where it's stored, and then read the data from a particular path, and then store it in a data frame with a particular name. So of course, the first part here, you could have data somewhere with this link here, and then you can use pandas to read the data, and then store it in a data frame with this particular name. And then from that point, you can now be able to get a summary of that data. What do we have in data? For example, like this one, if you open this, it's called Melbourne data. You can have a summary of it if you do describe on it, if you call the describe method on it or attribute on it, and you'll be able to see what you have in the data. You can see a range of columns here, from rooms, price, distance, a range of them. And then also you have rows here. I think there are about 8 of them. You have count, you have mean, standard deviation, and the different percentiles. And then, of course, you may also go and try to understand what you have in your data. Do you have missing values? Is everything okay? What's the average in your data? For example, count can show you how many rows that are missing in your data. And this one can give you the mean, or let me say the average in your data. Let's say you want to get the average of, let me see here, maybe land size. The mean will give you the average of the land size. So describe can give you all this, that can give you like a high level overview or a summary of your data. And then you can have like an understanding of the data. And then from this point, you're going to go to a coding exercise. Let me run it, then share my screen again. And also keep on checking on the chat. Brian is actively engaging you, sharing some resources so that you can also follow along. Okay, share screen. And to share exercise, then share. Okay, let's check the exercise. Looks like there's a draft saved. Okay. If there's no drafts, we'll do live coding. If there's draft, we'll just do a walkthrough over it. Yeah, it seems like you need to do a walkthrough over it. Okay. All right. So of course, you're going to go through this on your own as well, but you have a range of exercise that test your ability on what you've learned from the different parts that we've gone through. So we'll go through how a model work, and tools like and libraries like pandas. Then you have some exercise for them. Then we also go through basic data exploration, some exercise for them. We go through your first machine learning model, exercise for them, and that way you can be able to probably gain more technical skills from it. And of course, we're also going to use something called a notebook coding environment. It's almost similar to notebooks. You can go here, you can restart and clear all your outputs, start a session, stop a session. You have things like Markdown, code, is it thing? You can run the entire thing or just run one, delete, etc. And in this exercise, of course, we're also going to have some setup for you from Kaggle that generally just check if what you're doing is okay, or if it's complete. So let me just run this. And this ideally just helps you or just verify that what you're doing is correct or accurate. Let me see. All right, as it loads, I can walk you through to see what we have. Philomena talked about pandas. You can see we have pandas there, and it's going to help us to create a data frame. Of course, the first thing we're going to do is to have like a path with our data. Let's say CSV file somewhere. That's the path with the data, and then we're going to read the file and then store it in home data. Then I think it'll need to check if we've done that correctly. Is even the first one done? I think I need to take it step by step and to give it time. Okay, yeah, so setup is complete. You can see there. Then we'll go to the next one, this one here. Run it. Then it will tell you if you're correct or not correct. So this is correct. We've been able to specify the path for our data, and then read the data and store it in home data frame. And then now we can use the describe method we talked about to just check on what's in our data, what's in the rows, what's in the column, what's the mean, what's the count, the standard deviation. And you can see we have like 8 rows and 38 columns with this data. And this data is different from the one that we had. The first one was Melbourne data. It's called Melbourne. But this one is using Iowa data. So that's how it looks like. And then we can also check on, so let me see here. We can also check like the average lot size that we have. And what you're going to do is you're going to access lot area using home data. Not now, okay. And then calculate the mean for it. And after calculating the mean for it, we do rounding off for it to 0. And sometimes you may not know how to, let's say, do rounding off. For example, this one, the way I did it was I just searched how to round off. I knew how to do this, but I didn't know how to do rounding off. So I just searched rounding off, and then once I have rounding off, I could be able to use this and then plug in this into rounding off. Then I'll be able to round it off. But ideally, what you're trying to do here is access lot area in the home data frame, and then do a mean of the values in it, then round off the value from it. Then you print what you get from it. That's the first task. Let me run it. And then the second task is as of today, how old is the newest house? So and that newest house that they're talking about the current year and the date in which it was built. Okay, so the first thing I did was to just do it manually. Just take that today is 2023 and then go back here, check like the maximum year. Where's the maximum year? If I go to this row, year built, is it year built? Yeah. So year built, then I subtract year built from 2023. Then I have how many? 13 years. Okay, that's the first. That's the way I did it for the first time. But you can do this dynamically, where you can access the year built, same way we access the lot area. Then once you access those ones, you take the maximum value out of it, dot max, and then subtract it from this, and then you can print it to get how old the newest home is. Yeah, and basically that's what it is. So let's go see our first machine learning model. In case you have any questions, feel free to drop them in the chat. I'll try to answer them, but you also have other experts here who will ensure that we try to answer your question. Okay, second part, your first machine learning model. All right, so we're here again. Okay, I'm just checking if I have my stuff. Yeah, I have my code, but I don't have my code. Okay. Yeah, so we've seen the table, we've explored and seen how it looks like, but you may not you can see that you have like a lot of variables in that data. And of course, when you're building all this, you usually have the variables, you have the labels and the target variables. And you may not want to use like all the variables that you have in your data. They're just some specific variables that make sense to you, or that you may want to use when you're training your model. You may not want to use like all of them in the table. So probably you may need to find a way to just access the one that you need to use. Which one can you use as the X input? Which one can you use? Which variables do you just want to use as the X input? X1, X2, and the other X's. And of course, still we're going to use pandas here. The pandas attributes to access different parts or different things in our data set. We can choose the columns that we need. For example, you can go here and I think the first thing you do is to like list all the columns that you have. Now I have my data set. Can I list all the columns that I have? And then in that columns, can I now be able to select the ones that I'd want to use? So we've talked about this first tool where you have a path, create a data frame, and then this data frame, you can just do .column to see the list of all the columns that you have. You can see here suburb, address, rooms, bedroom, year built, and all these. And we may not need to use all these ones to build our model with it. They're just some specific ones that can help us to, let's say, get the pricing or the pricing of the house that you want to get. And sometimes you may also have, let's say, missing data values, and there are ways to remove these missing data values. For example, here there's this thing called Melbourne. This is called drop na, and na just means not available. So you can just call drop na on this, and then you'll be able to drop the missing values. And of course, and then after that, of course, you need to get your features, and then show your model what your features are. For example, you can get a bunch of all these features, then tell them that these features, this is what they mean. This is the label for it. Or this is the target that you want to get. So you can use, let's say, dot notation to select the column that you want to predict. And this is usually the target of what we want to predict. So for example, in this case, our target is pricing. So we can access mail.price, then store it in in a prediction target called y. Then we go and choose our features. Of course, we have a range of features, like I showed you, a lot of them, but we may not need to use all of them. So we need to select the few ones that we want to use. And for this case, we've selected a few of them, including rooms, bathroom, land size, latitude, and longitude. And then we'll save this in something called X. And what you're going to do is that we're going to create like a list. This is like a Python list. Then use the data frame, use Melbourne data to create a data frame that we can store in X. So at this point, we have our X features, and we also have a target label with a prediction target with our data. So we have what we need to predict, and also the features that's in our data. We may want to check what we have in this data, describe it, just to have a quick overview of what's there. And you can see here you have rooms, bathroom, what you already have, the count, mean, and all this. And you may also, that's just a description of it. Philomena also talked about head, where you can do x.head and just have some few of them listed. I think usually the 5, 1, 2, 3, 4, 5. Yeah. So by default, the 5. I think the default argument here is 5, but you can put 10 or 20 or the number that you want to list them here. So yeah, and then from that point, now we're going to kind of build our model. And to build this model, it involves mathematics. You can decide to do them on your own, but you may not be able to do all of them because there are a lot of variables. There are a lot of features and a lot of things involved in it. So probably it's just good to use a library like scikit-learn to do all this. Of course, the first process is to, it's called define. Check on the kind of model we want to build. What kind of algorithms do you want to use? And then there's something called fit. Fit is where we try to build our model. We try to make our function model the data distribution that we have on the Excel sheet or on an image or on whatever. And then after doing that, we then make a prediction to it. Then once we make a prediction, we try to check how close is the prediction from the true value or the ground truth. So we define what we want, check on the type of models we need, and then after that, we then train our model or do the fitting for the model. Then once we do the training or fitting, we try to make a prediction or try to make a guess. Then once we make the guess, we check how far the guess is from the actual value. Then once we have that difference, we can start to do evaluation. Ideally, that's what evaluation is. You can start to do evaluation with it, and even think about later how to optimize it. But let me just leave it at evaluation since this is an introductory part for it. And at this point, probably you may be wondering the kind of algorithms to use, the range of them, and Brian is going to take us through all of them. But usually, if you don't know where to start with one, what you could do is, let me just share my screen again. Share screen. Right now there's just GTP, but you can also just go somewhere here. Let's say decision tree classifier, scikit-learn. Then open it. So we have this one here. You can just go and open it, see what it has. This is the documentation, the API, the library. Then go to that library. You'll see that this is the class. And if it's a class, it means that we're going to create an instance of it, an object. And then when you create the object, we have some arguments in it. And here is where you can check which arguments are what are the mandatory arguments or the required arguments, and which ones are not required arguments. For example, decision tree, you can see things like minimum leaves, splitter, and all this. But this is just to guide you on what you have, the class that you're having, and the arguments that you're going to have in that class, and even how to use it. And if you don't really know where to start, just open a notebook and then come to the example, copy this and run it, then see if it loads and how it runs. You can see, for example, in this one, you're going to like get some data sets. You're going to load iris data sets from sklearn data sets. And then we're going to talk about cross-validation. Don't worry about it now. But you can also get decision tree from sklearn tree. Then we create like a classifier here. Then, we instantiate the class, already create the classifier. We have decision tree classifier, and then these are kind of an argument that we need to pass through random state. And then we can load our data sets, then do the fitting and all those. But this is like the Bible where everything is. You just come and learn how to use the different classes for the algorithms. And I think they also even take you through what a decision tree is. If you click on this one, they'll tell you what a decision tree is, its advantages, disadvantages. Let me just run. I think this example I was looking for. Yeah. Advantages, disadvantages, how to do the fitting, what you have X and Y. And once you go through this, at least you'll have like some basics of how to get started. But let me go back to what we have on the other side. So share. Let me know if you can see my screen again. Okay. All right. So, and with this one, you can have, let's say, decision tree regressor. You can just go Google decision tree regressor, sklearn decision, just be good with Google. And then after that, you can see how to import it, how to instantiate the model, what's a random state, the kind of arguments you have in this object, in this, how to say, that you've created. Why do you need to define like the random state? Does it affect anything? And then after that point, of course, you fit your model, or ideally make your model learn the X features, so that next time if you show it Y features, if you show it a new X value, it can give you a prediction from it. Okay. Then after this point, we had the data set. We're using this regressor, and regression is trying to predict continuous values. So then we use it there, fit. After fitting, we can try to, let's say, get the head of all the X's. Philomena talked about this. Then check the predictions and how they are. Okay. Then after that point, Kaggle will also give you a chance to do some exercises. Let's go through it. Okay. It's open. It keeps on opening a new tab. That means every single time it opens a tab, I have to share and reshare. Stop sharing and share. Okay. I hope I have the code as well here, because if you don't have the code, you're going to do live coding. I hope it's saved. Okay. Yeah, it's actually saved. That makes our work easier. We'll just do a walkthrough. Okay. Now you know this very well. As a recap, just use pandas to create a data frame. And of course, when you're creating the data frame, you need to load it somewhere. You have a path somewhere that you've specified. Then read the CSV, then have a data frame with that name. And then also you're having pandas here checking what, not pandas, but Kaggle, checking what you're doing. Is it correct, not correct, and telling you if it's complete or correct. Okay. And this is an exercise. The first thing in this exercise is to specify the prediction target. And you remember that for us to do this, first of all, we need to see like how many columns do we have, because you may not necessarily use all the columns. So we need to print like a list of columns and then find the name and to see what we need. So if you run this, I think it has already run. Wow. Okay. Let's just go through it then. Then I can have like a list here of a range of a lot of things here. And now I need to decide, okay, which features do I need to use, or which columns am I going to use in my training. And then, of course, first of all, we need to determine what we're predicting. We need to specify the prediction target. And our prediction target is price, this one here. So I just store it in Y. You can run it, or even maybe I can print the heads that we see, like what we have in it. Okay, let's see what we have in the head. All right. Yeah, so you can see like a list of pricing for the houses. Yeah, and we also stored them in a variable called Y. And I'm just listing the first 5 of them. Of course, I can list like 10 or whatever. Then let me go down. And then now we need to create X, because we are building an equation or a model. We have to have an equation. We have to fit the X's with the Y. And in this case, we're going to choose these ones as our X, or our features, predictive features that we want our model to learn. And the first thing you do, you can create a list, a Python list with the features, and then use the features to create a data frame, then store them in X, because that's correct. And then after that, we can, what's happening? Okay. We can like describe and see what we're having. Same way you can see. Then you can check on the head. Head gives you like 5 of them, but you can decide to choose the number that you want to see. And when you're okay with it, now you can move to. When you're okay with that, at that point means now you have the features you need to train your model. Now you're ready with the features. You have your target, you have your features. What's remaining is to make your model learn from the features and to be able to make predictions. And then the same way I've shown you, of course, we're going to use decision tree regressor from the scikit-learn API. It's a class. We need to instantiate it. There it is. And then you can check on the arguments that the mandatory arguments, or the arguments you need to specify. For example, here we need to specify random states, and then we fit the model, of course, X with Y. Then now we have our model, and that way we have our first machine learning model. But that may not be enough, because we still need to make a prediction and see if we can get answers from the model. So I can go here, make a prediction. Wow, I think I'm yet to run the upper layers. I'm yet to run the upper layers, but let me just walk you through them, because I think it will take time. What's happening? Okay, I'd run all of them. I think, okay, let me just see. Okay, that's complete. Then we have that. Then I have head. And then let me see. There's the head. Then we want to put it in a different way. Show the head. Okay, let me just maybe do to list. Nice, I want to have this way. So to list, let's have them that way. And then, of course, I have X and Y. Wow, I was supposed to run them. Okay, we have that. And then I've talked about this. Then we have it, correct. Then we can now describe our data. Of course, we already have it there. I don't think these are necessary in the other layers or in the upcoming one. Then now we fit our model. Hope it should run. Okay, now it's running, fit the model. Then after fitting the model, now we can do our training. Perfect. Now you can see, we can do our predictions. And now you can see the predictions that we have. And then maybe you can check our predictions and compare the two. So we trained a model. Now let's do a prediction and compare the two. So if I run this is what I get, but I'm not listing them in the way I need to list them. Let me add dots. Let me add that one so that you can compare them side by side. What am I not doing right here? Head. Okay, I'll delete later. Okay, you can see that this is the value. With this, you can see it's almost the same. Not almost the same, but it's the same. This and this is the same. This and this is the same. They're like almost the same. And probably this could tell you that there's a problem somewhere. It's very, very accurate, extremely accurate. And that probably means that it's probably just learning some specific features to a point where if you show it like a new example, can you guys hear me? I think it's my internet. Can you hear me? Can you guys hear me?
Yes, Gessa, we can hear you.
Okay. That's some issue with my internet. Okay, share, validation. Okay, let me just walk you through this. I can see that my time is over, but we have to fix it. Okay, all right. So what's happening? Okay. All right, my slides are not showing anything, but I can remove them anyway. So with validation, what we're trying to do is we're trying to check the quality of our model. We're trying to see how different is what we predict from how different is what we're predicting from the ground truth. And then from that point, we're going to go ahead into things like what's underfitting, what's overfitting, and even how we can optimize our model to ensure that it's just right from what it's supposed to give you. Okay, from that point, I think I'll take questions if we have, then hand it over to Brian. Do you have questions? Let me probably just check on the chat here. Good evening, Nairobi. So, I mean, if you just want to do like a university project, or just want to do some prediction, build some models, then don't necessarily have to learn the maths and all this. You just know the basics, the linear algebra, the statistics, the calculus, just the basics that can help you to like work with your model. But if you want to contribute also organize them, where we take you through linear algebra and how they can help you to extract features, let's say from an image, or how they can help you in data representation. Then we can show you that. We can also go through things like calculus and how calculus help you to optimize your model. How you can have like let's say what it's called a loss against weight curve, and how you can use differentiation and chain rule to go down the curve and ensure that you have the best weight that gives you the least loss from that curve. And of course, for you to get an output, you need to have some probabilities. So there's some probability somewhere. So there's some maths involved in all this. And tools, libraries like Keras, libraries like scikit-learn allows you, abstract all this mathematics and allow you to be able to build your model without really worrying about the deep mathematics that's happening underground. But of course, if you want to contribute to the industry, then you need to know all this mathematics. You can find the content here. Thank you, Brian, for sharing. Again, thank you for joining us today. Can you share the link to the first notebook by Philomena? Yeah, we'll share that. And yes, the tools like Vertex AI with Model Garden. It's a very nice tool. I think we'll also have a session on how to run your model in the cloud, build, test, how to access all the tools for Google in the cloud and use them to build your machine learning models. And also how to do your MLOps in the cloud with tools like Vertex AI. We'll have more of those. Let me just check if there's any other question. Share books. Yes, we're definitely going to share the books. Okay, all right. I'm not seeing any other question, but I'd love to stop there and hand it over to the next speaker. Once again, thank you for listening to that session. Over to you, Brian. Can you hear me, Brian? I think you're on mute if you're speaking. As wait for Brian, someone is asking about a WhatsApp group. Yes, we can have a WhatsApp group, number one. Number two, we also have what's the name? We also have a link to our past groups. You can share it so that you can use it. Brian, I can't get you, Brian. Can you hear me, Daisy?
Yes, I can hear you.
Okay.
Yeah, Brian, we still can't hear you.
Brian. Okay, so we have a group. I can't get Brian. But anyway, as wait for.
Sorry, Ngesa, as we wait for Brian, I was going to suggest that we look at the Kaggle competitions bit, right?
Yes, Daisy.
Okay. So you can just add my screen.
Yes, let me add it. Let me see. I can't see your screen.
Give me a minute.
Okay.
Just share the entire window, yeah?
Okay.
You should see it now.
Yes, I can see it.
Okay. So, guys, in the interest of time, I'll just keep this very brief. So, as Ngesa has already mentioned, there's a section, right, where you go to your exercises. As you look at your courses, as you look at your sessions for week 1, the last session that we have here is called Machine Learning Competitions. And just a bit about machine learning competitions is that, one, apart from getting at times money, you also get the bragging rights, and this can go into your portfolio. So when you go in for a job, you can always say, I did such and such competition and I came in first. I mean, all the best to you. Or you came in 10th. That just goes to show your employer that you're someone who pushes yourself. But apart from that, it's also a learning opportunity for you to do. So once you come to the last section of your course, you see that there's different segments here. This is an example of housing prices competition, and this is largely for knowledge. When you go to overview, you get to see an overview of what the problem really is here. When you go to the data segment, you get to see the data subset that's being used here. Most of the time, you have your train set, your test set, and then your submission file, rather, what your submission file should look like. And then when you come to the notebooks tab here, at times you can see notebooks that have already been submitted. That just to guide you. And for discussions here, you'll see there's usually open forums where if for this problem, someone has a different insight to it, or you have a question, you can always ask. And then for the leaderboard bit, you get to see how well you perform against your peers. So I'm rooting for you to be fast. You want to be on the top of the leaderboard, but of course that takes time, that takes practice. And just a hint, you find that some recruiters really use the leaderboard for recruiting. So case in point, my boss where I work was the best ranked data scientist on Zindi for the longest time. And you see that that really goes well onto his resume. If he writes that probably anywhere on LinkedIn and you're looking for someone to come on your team, you find that it really sells you. And then there's your rules. So things you can and can't do, it's always important to go through this. And then you can always form your team in good time, way before the competition starts. And then every other time you get to submit your sets of prediction over time, as you work to like get the best results. The next view here is just largely to start the exercises where you get to have a view that Ngesa was talking about, where you get to see the actual Kaggle notebook. And I think Ngesa has already catered to the basics that I thought I would cater to. That includes maybe running a cell, running a code cell, and stuff like that. But then also when you look at Kaggle competitions here, you can see the competitions that are currently active. And here for the first 4, you see the amount of money that's going into this. So you find that this is around 20 million that's been put out, 20 million Kenyan shillings that's been put out there for you to participate in this challenge. And if you're good enough, you can either hone your skills or win the prize, take it home at the end of the day. So you can either go for the money, but you can also go for the knowledge. So if you're a beginner, I'd advise that you go through some of these sample data sets and get to practice with them. But over time, you can also improve on the level of kind of problem you're trying to solve. Go with maybe what's marketable in the market. Maybe you might want to put this onto your portfolio so that it sells you better. So the competitions are meant for knowledge, and the competitions are also meant for swag. So you just get to win swag for participating in it. And usually for a competition, you see that there's the prize, there's the teams that are already participating, and then the amount of time you have left to participate in them. You see there's this one that's already ongoing, but that's largely because it's a knowledge-based competition. So maybe if you're looking for work or if you're trying to upskill, I'd really advise that you use Kaggle a lot as a resource. This is one of the platforms that has open sourced data sources. I mean, data sets for most things. Zindi just does that for African data sets. So when you have time and you want to hone your data science skills, just take up a competition, do your submissions, learn, engage on the discussion of or open forums, get to learn a bit from your peers as well. And you find that that puts you steps ahead of your peers, even as you're learning, as you're networking. Yeah, Ngesa, that would be it from me in the interest of time.
Thank you, Daisy. Let me check if Brian is back. Brian, can you hear us?
I can hear you. Maybe you can add me. You can
Perfect.
hear me now.
Loud and clear, Brian.
Oh, thank you very much.
You could try
Okay.
share your screen. Then I check it for you as well.
Yeah, I think I had my presentation already ready on your end.
Let me see if I can get it. Let
Okay,
me
sure.
see. Yeah, there it is.
Okay. Yeah. Thank you very much, everyone, and thank you very much, Daisy, for coming in for me. And also, thank you very much, everyone, for making time to come listen to us today. So I'm not going to talk about the machine learning algorithms. So we started with Philomena. Philomena talked about Pandas, NumPy, Matplotlib, and all the basic libraries. And we had Brian ask, okay, are we going to be library junkies or are we actually going to go into the maths? So Brian, I hope you're here, and this is the part for you. Also, we had an interesting question from Terry. So before I proceed, maybe I can answer it first before I proceed. So we have many libraries currently that have really democratized machine learning. So machine learning has become more accessible thanks to libraries like scikit-learn, TensorFlow, and all the amazing tools that Microsoft is building, Google is building to help abstract all the knowledge from, let's say, users or people who want to add machine learning into their products. As a matter of fact, it has become so accessible that very few practitioners actually take time to understand what happens under the hood. So what happens under the hood is important, and I'm going to share with you why actually that is important. So as machine learning is increasingly becoming commoditized, those interested in machine learning, you should take time to understand these algorithms intimately, the ones I'm going to share today, so that you can stay competitive. So apart from just staying competitive, responsible AI, we can't be risking to trust black box models. That is, you can't just, because it is abstracted from you, can't just risk trusting black box models, and just from lack of insight to what is happening, to complete misuse will often outweigh the benefit of convenience. So however much they bring convenience, but you also need to understand before you even go and try and use them. So I've tried to answer Terry's question as much as possible, but feel free to indicate in the chat section if this assisted, and also you can continue the discussion on Discord or while I continue the presentation. So let me go to the next slide. So now let's narrow it down. I'll be talking about machine learning algorithms. So I'll be talking about decision forests. I'll share with you about linear regression and k-means clustering. I'll share with you logistic regression and naive Bayes. So for someone who is already into machine learning, this can be so easy for you, like to catch everything up. But for someone who maybe is starting out, don't be scared by what I'll share, the decision forest, or we are hearing k-means. So what is k-means? Or the naive Bayes. Don't be scared. It is something that you can actually pick up. And that is why I'm here to explain it to you in very simple terms that it will be very easy for you to pick it up and try it out in one of your exercises on Kaggle or just for fun. So the basis of any machine learning model, or the basis of what you're speaking about, the AI, the model garden, everything that you're talking about is data. So we need to really understand our data before we even go into what the algorithms are and everything is. So can you explain the features in your data? So to start, we have to understand what types of data we deal with on a daily basis. So can you explain the feature in your data set? And by a data set, I mean just a bunch of data that is organized in a way that you can access and query them easily. For example, here we have a table that has addresses, income, age, and education. So it's easy for you to access that and query it. And when I say features, features are characteristics about this data set or about the data inside of that data set. So let's say, for example, we currently have APA Festival going on in Nairobi, the first of its kind in Africa. So if you are attending API Festival, let's say tomorrow you'll be part of the audience. So Marvin Gessel will be giving a talk tomorrow. So if I want to get features, I will say Marvin Gesser. Some of the features about Marvin Gesser is that he's a speaker. What he will be speaking about, he'll be speaking about Kera's CV. So you'll see what room will he be speaking about, the room he'll be speaking about. So I'm able to get the characteristics on and different things about Gesser apart from just knowing it. So also here we can get the address of that person, the income, the age, and the education. So you can see that in this first example here, where you have this data, it's very easy for you to, it's so easy for you to get the features. But in the second image, it is pictures. So, and in pictures, features are in terms of pixels. So we have you can see there is pixel 1, pixel 1, 2. So images are in terms of pictures. And when I say in terms of pictures, when you're given a pixel, you're viewing them in terms of, let's say, RGB, red, green, blue. So when you're given a single pixel, it will be very hard for you to say, okay, what is in this pixel exactly, when it is very zoomed in, what is in this pixel. So which is also very interesting. And I guess I'll be talking about it more tomorrow. So tabular data is known as structured data. The one above here has address, income, and age. This is tabular data. And the one below is unstructured data. It is structured data because you can easily explain the features that exist in that data set. So let me go to the next slide. So here we're going to talk about decision forest. So this is also one. Now we're diving deep into everything. So we'll start with decision forest. So what is a decision forest? First of all, let me start from general knowledge. A forest contains trees. So that is not different also from decision forest. We also have what we call decision trees that come together to form a decision forest. So let's see. So we have different types of ML models and algorithms. So for example, in the first part, you can see we have a decision forest. And in the second part, we have a neural network. So in the decision forest, you get, it's like you are deriving, it's yes or no, till you get to your correct answer. So here you can see that if I'm saying the number of legs are greater than or equal to 3, if it is yes, then go to the second feature. If it is no, then it is a penguin. Or if it is also in the number of eyes, if it is they are greater than 3, it is a spider. Or if it is no, it is a dog. So you see from these features, we are able to get our what the animal is, which is a dog. But in the other, that is neural networks, we'll also get to cover this in this study jam. So I've not even included it in this algorithm because we'll have a session of its own to talk about neural networks. So let me go to the next slide and now explain to you what a decision tree is. So we've seen that you have decision forests, and decision forests are made out of decision trees. So a decision tree is just a collection of questions or conditions organized hierarchically in the shape of a tree. So you can see here we have these questions, that number of legs and number of eyes, and they're organized hierarchically. So the first question or condition is what we call a root, and then the second question is, they are just called non-leaf node, and then you have the condition inside it, and then you have the leaf node that contains the prediction inside it. So when you're making predictions, it is very fast. So you start from the root, answer the questions until you see the leaf node. And we've said that the leaf node is what contains the prediction. So you define conditions, and these conditions are applied to the features of your data. So let's say if I define number of legs, they are applied to the features in my data, which of course I must have legs. So if I'm having a condition about legs, then that means one of the features in my data is legs. So if I'm having a condition about eyes, one of the features in my data is an eye. So that is what a decision tree looks like. So, but even we have this proverb that goes that one tree cannot make a forest. One tree cannot just do it all. So we also need to have a decision forest. So a single tree has a limited expression. But when you compute many trees, and after computing many trees, you now come together and see, okay, what is the best out of this? Which one has, from the three that I've computed, you get them together and see the best out of them. So you get a prediction from it. So that is what we call a decision forest. So what are the benefits of decision forest? They are of excellent quality. They are very easy to train. Even when you are the model you'll build on the introduction to machine learning course on Kaggle, which we'll be doing this week one, you will be doing what you'll also be using Decision Forest. So it's of excellent quality. It is very easy to train and it is very fast. Very fast, I mean, compared to neural networks, so where you have different layers and you have images, you have these images that have to go through the different layers, then you get the output. So you can see all that process compared to Decision Forest. And also it is easy for you to interpret what I was saying earlier about explainable AI. So it is easy for you to explain how you reached to that decision when you're using a Decision Forest compared to when you're using black box models such as neural networks. With Decision Forest, it is very easy for you to explain how am I arriving to to this this answer. So let's see the different types of Decision Forest. So for the different types of Decision Forest, we first have what we call the cards. So this is just like they just stimulate human experts. They are easy. For example, let's say we have, for example, I'm going to use Wayne Gaku. So we have Wayne Gaku. Wayne Gaku is a GDE in Angular. So if you reach to Wayne Gaku about anything Angular, it is very easy for them to answer you. So they like easily get to answer you. So you'll be like, oh, I have this question about this and this. So can you help me? So it just stimulates human experts. So it is very easy for you to understand this. And one advantage of the cards is they're interpretable, and but they also have a disadvantage where they have lower quality results because it's only one person I'm asking this. So I don't have like knowledge of the crowd or wisdom of the crowd. Also, overfitting is one of the risks that you can have. And then we have random forest. So with this, we can easily get overfitting. But when you go to random forest, we are randomizing everything and you're getting wisdom of the crowd. Wisdom of the crowd, I mean, in this call, we have me, we have Victor, we have Philomena, and we have Daisy. So all of us give their answer to a question. So let's say an audience ask a question, all of us gives an answer, and then from our answers, let's say I say the answer is A, then one person says B. So we'll do the wisdom of the crowd and say, okay, probably the correct answer here is A, since most of them have said A. So you say like use the wisdom of the crowd, and since it is randomized, there is less overfitting, and it is also efficient. And as, of course, it is a self-evaluating model, but it has a disadvantage when it comes to you building very large models. And now let me explain the gradient boosted trees. So for gradient boosted trees, let me again use an example of Wayne Gaku. So here you want to perform different tasks, but we know that you cannot be a jack of all trades. You have to master your trade. So Wayne Gaku is good with Angular. And then probably you are doing Angular, but you also want to do communities. So you reach out to Tabitha Carview. Tabitha Carview helps you out with stuff to do with communities and all that. And then you also want to do Keras. You reach out to Marvin Gesser. Marvin Gesser helps you out in terms of Keras. And then you want to reach out in terms of advocating for more inclusion in the data space. So you reach out to Philomena. Philomena helps you connect with women in data, and you help build. So you see, like you're utilizing the specialty of different person. So in this gradient boosted trees, it's different trees that have different specialization, and they're helping you get excellent quality in that specialization. So of course, if I reach to Wayne is very good in Angular, I'll get a very good answer to my Angular question. If I reach out to Tabitha Kavi is very good at community management, I'll get the best out of my question. So I hope you get to understand what is gradient boosted trees. An advantage of it is very fast and it's of excellent quality. Excellent quality because I explained you get the best out of each. But here also overfitting is very, very much possible. So let's go ahead, and so I'm sharing this resource. So don't worry, you can scan this QR code right now, or I'll also share all the resources I'll mention in this talk when I'm done speaking. So I'll also in the Q&A section also get to share resources with you. So you can check out this Decision Forest class by Google for developers. So they have a specific course to learn Decision Forest. So I feel it's very good and you can learn most from it. So feel free to check it out. So let's go to the next algorithm, which is simple linear regression. Of course, I'm mindful of time and wouldn't want to keep you any longer. So with simple linear regression, so in regression systems, we output a number. For example, let's say, how long will it take to drive from point A to point B? So let's say tomorrow Ngesa will be speaking at API Festival. So how long will it take for Ngesa to move, let's say, from where they stay to the venue of the event? So they want to use a regression model to give them that. So they'll use regression systems output a number. So that is what they'll use. And regression models can be simple or more complex depending on mathematics part. Brian asked about, okay, are we going to do maths or don't do maths? So here's where we are going to do it. So I'm going to start with an example. So let's say you want to convert degrees Celsius to degrees Fahrenheit. We have a formula to, you can do a maths, you can have a maths formula to convert all that. And that maths formula is just a linear function that goes y is equals to mx plus b. So you already have Celsius and Fahrenheit values that you will use to gauge. So you see these red dots are Celsius and Fahrenheit values that you will use to gauge how accurate is your model. And then we already know the x and y values from our existing data, the red points. So you see these red points you're able to see in this graph are the values that you already know. That is the degrees Celsius and Fahrenheit that we have, that we are feeding our model. I explained that models start from data. So this is the data that you have and you're feeding it to the model. But the missing information is what is M and B. So with traditional programs, you feed in an input, you create a function, and then you get an output. But with machine learning, you feed in an input and an output. You let the machine jumble up everything and do some magic, and then it gives you an output. And then it learns from the input and output so that when it sees new inputs and outputs, it is able to predict the right output. And that is exactly what you're doing here. We know X and Y. We've given them, let's say, 0 degrees is equals to this number of Fahrenheit. So we have the X and Y values from the existing data. So now we're trying to find the line of best fit. So we did line of best fit, probably in high school or yeah, somewhere we must have come through line of best fit. So when you're building a model, actually, what you're trying to do, you're trying to come up with the line of best fit. So you see now you need to understand the mathematics behind what is happening, even when you're building your model. So that's like a simple, like I wanted to keep simple things simple since this is our first session. And in our next sessions, you'll be able to see even deeper stuff. So you can check out this simple linear regression demo that I created. You can scan this QR code. Again, I'll be dropping all these links in the chat section just after this call. So don't feel like pressured when you're missing out all this stuff. I've also added like step-by-step explanations in this demo. So you're able to like go through it and understand all that stuff that is in it. Clustering is, so you probably had k-means clustering, k-means clustering. So what is k-means clustering? Again, the beauty of mathematics, we can see it here. So this is just a type of unsupervised machine learning algorithm. So k-means clustering groups up points based on a specified number of centroids. So with clustering already, you understand that you're clustering things together. So let's say we are clustering, we are trying to, I'm building a solution to help mitigate female genital mutilation in the Horn of Africa. So I'm trying to group cases according to their country. So I have cases from Somalia, cases from Kilifi, Kenya, cases from, let's say, Vihiga, Kenya, cases from Egypt, all those cases. So when I'm clustering this, this is an example of clustering. So K means clustering groups up points based on a specific number of centroids. So now what is a centroid? A centroid is a best fit center for cluster points. So in the linear one, you use like we also finding a best fit. But now here we are clustering. So we also need to find a best fit here. So we used what you call a centroid, and a centroid is just a best fit center for cluster point. So to the right, you can see some data that is in, let's say you can see the red spots, the yellow spots, the green spots, and the blue spot, and you can see we have 4 centroids, which we are using in our k-means clustering. So you can also check out this k-means clustering implementation. You can scan this QR code or just go to the link, but I'll also share all of this in the chat section. So don't feel like, oh, I'm left out. No, no, don't worry. I'll share all of this. So now let's understand what logistic regression is. So logistic regression is a classification tool that predicts a true or false value for one or more variables. So you can have one or more variables inputting into from our data, and you're now trying to see is it true or is it false. So the training data must have outcomes of 0, which is false, or 1, which is true. But the regression will output a probability value between 0 and 1. This is what Ngesa was saying. It will be like we are dealing with probabilities. So the output can be 0.69. When you get 0, let's say 0.89, you say like, oh, my model is kind of accurate. And when you get 0.6 something, you know, okay, my model is 0.5, 0.0 something, your model is not doing really good, but that may not be the case. So an S-shaped curve, a logistic function. So in the right side here, you can also see this is what a logistic function looks like. So if a predicted value on the y-axis is less than 5, it is typically recognized as a false. And if the predicted value is greater or equal to 5, it is predicted as a true. So you can see this is the maths behind logistic regression. So this every single algorithm here can take a whole session of its own, but I tried to bring things together and give you an overview just to spark your interest for the next coming 4 weeks as we delve deeper and deeper into each of these algorithms. Now, to the most interesting one, we have knife Bayes. So everyone pronounces this in their own way, but let's see what this is. So knife Bayes is a machine learning application of the Bayes theorem that merges probability of multiple features to predict a given category. So let me now break this down in an even simpler way for all of you to understand. So it is often used to classify text, e.g., email as spam or not as spam. So you see the way Google classifies your email as spam and not as spam. Probably they're using what we call the knife Bayes algorithm. So knife Bayes is effective because it learns quickly even with little data. So it is really effective because it can learn quickly even from little data. And knife Bayes works by mapping probabilities of each individual feature occurring or not occurring for a given category. For example, if Google notices that the word, let's say the word decision appears in many spam emails compared to not spam emails. If your email has the word decision, then it will be easily classified as spam because that is a word that easily appears in many spam emails. So while this is commonly used in for discrete variables like words, it can also be used with continuous variables using statistical distribution. So Brian, this is the interesting stuff you wanna hear, like statistical distribution. This is interesting stuff. And for the next weeks, we'll be going into all of these amazing things together with all of you to try and dive deep.
I think I lost you for some few seconds, Brian. Can you hear me, Philomena?
Can you hear me?
Now I can hear you, Brian. Go ahead,
Oh,
proceed.
thank you, thank you. Thank you. So let me go back. It means maybe you lost me some part here. So I was saying this is used mostly for discrete data, but it can also be used for continuous data with, of course, some statistics into it. So this is the interesting stuff that Brian wants us to go into it, and we'll be going into it in the next coming weeks. So yeah, I have tried to cover the algorithms in a very short time, but this is something you can take days to only cover one algorithm and help you dive deep into it. So I hope this sparked some interest into you with all the mathematics, the graphs, all that. Intentionally, I placed all that so that I don't abstract that actually maths exists in machine learning, and we'll be going into it together. So I hope this sparked some interest, and you can find all the resources, everything I mentioned in this call. You can just scan the QR code there and you'll be able to find everything. So back to you, Ngesa, and let me check the comment section if you have any question.
Thank you, Brian, for the amazing sessions. And yes, math is it's also very exciting if you know what's working behind it. If you know that what I'm doing right now, the way I'm extracting the way I'm representing my data, I'm using linear algebra, and probably the way I'm working with these layers, let's say, is in the planning. This is what's happening. And now where I am, probably I want to reduce my loss, and I need to use some calculus, or I need to display the output of my model. I'm using, let's say, softmax. We'll talk about this later. Don't really worry about them for now. Now I'm using probabilities to give me like the output from what I'm having. So math is very important, especially if you want to contribute more to this model. And I think we really have a nice session. We've gone through a range of things, from how a model works from pandas to how a model works. We've also gone into basic data exploration, of course, building on top of pandas. How do you work with data frames? How do you use things like .describe, .head, yeah, to see what in your data? We've also checked on validation. How do you check on the quality of the model that you're building? And then we've dived deep into, not deep, but we've dived into different machine learning algorithms. And I can also see that you guys have been asking questions. I think there's one here by Brandley Okeno. And the question is, what is it? I would like to know what processing methods you'd want to use to get a low error value in your machine learning models. Like, for example, I made a model, but the mean square error was 114,000. So yeah, when you do all this, of course, there's some pre-processing methods that you can use or you can consider to help you reduce the error that you're having. And the good thing also is that in our next session, we're going to cover some of these pre-processing techniques, including things like data cleaning. So in data cleaning, we'll be able to see how to remove or handle missing values. Remember in the first, I think the Melbourne data set, they were shown how to remove how to drop some columns. How to drop some columns or even remove missing values. So we're going to go deep into this. There's also feature engineering. How do you create relevant features that might improve, let's say, model performance? The things like feature selection. Which kind of feature are you selecting? Because you can have a group of features on this side. For example, we had like a range of features, but we decided to select some features from the group of features. So how do we like select the right features to give us a better performance? Probably those are some of the things that you can consider when you're doing pre-processing to ensure that your model works well. But maybe if my colleagues also have something to add, they may add on the question. Okay.
Ngesa, maybe just to add, to ensure that you're putting the best models out there, make sure to work on feature creation and feature engineering. You also want to tune your hyperparameters as well. That way, you'd increase your chances of getting better scores with your model.
Totally. Yeah. Thank you for that, Daisy. Someone is also asking that we mentioned that there's a Discord channel. Yes, we have a Discord channel. There's a Discord channel we use for our cloud and ML study jam. I think we're just going to build on top of it. And we're going to share the link. Actually, the link has already been shared on Twitter. If you go to our Twitter, GDG Nairobi Twitter account, you'll be able to see the link to join the Discord channel. So please join it, ask your questions. We'll be sharing more resources on that link. It will be a place where we can do peer learning. We don't necessarily know everything, but we can share what we know and also learn from you in what you know. And I think that's what we discussed today. And just to build up on the question that the person has asked, next week, from the same time on Thursday, we're going to go into intermediate machine learning. And this intermediate machine learning, we're going to see how to handle missing values. How do you handle missing values? How do you handle non-numerical values? What is data leakages? How do you do, what is categorical variables? What are pipelines, cross-validation? You remember when I went to the decision tree classifier, there was something called cross-validation, and I told you that I won't talk about this. I'll talk about it later. Probably after this now, it will be like the perfect moment to talk about it. But we're going to talk about cross-validation, XBoost, and even data leakages. So the same way you've come today, please join us next time so that we can dive deep into this and even build on top of the knowledge we've got today. So, and also that will just be the week 2. Week 3, we're going to go into deep learning, into computer vision, and then week 4 we're going to do time series, and then do also an intro to AI ethics. But remember, all this is a build-up for some of the biggest ML events we're going to organize this year. We're going to have a Keras Day Community Day in Nairobi, and then a Keras Community Day in Mombasa as well. And this is to ensure that before you come to our event, at least you have some ML basics so that you're able to contribute in our event. Is there anything I'm missing, Brian?
No, I think you mentioned everything, but just to add, please join the Discord channel and feel free to ping me, ping Gesa, ping Brian, ping Daisy, and we are all there to assist you. Also, your peers are there too to help us all learn together. GDG Nairobi, we are very heavy on collaborative learning and making sure everyone has a safe space to thrive and learn and build their skills in machine learning. And that's why we are here to help you out. So also for GEMS, you can join the Discord channel, and we already have the existing ML channel. We are not using a new channel, just the one we had. So thank you again very much, everyone, for making time. It's 9:42, and this shows your dedication for staying up to this time. Thank you very much.
Okay, thank you, Brian. And also, if there's some contents you'd want us to probably discuss even beyond this, let's say content on Keras, content on TensorFlow, content on machine learning, or in cloud, feel free to make for us these suggestions as well. Then we'll know which areas should we focus on, which speakers can we bring, what kind of content do we bring to our YouTube channel. But I don't know if there are any other extra question. I can see it's 9:43. Okay, all right. So since there's no any other question, I'd like to thank all of you for joining us this evening and for staying with us until now. Thank you so much for joining. Have a wonderful evening. Bye.